Okay, in this tutorial we are going to look at an application of calculus where we have to differentiate a function that's nested inside another function. And the way that we do this is by using something called the chain rule. Okay. Best to look at an example and then back out into theory. So let's clear the workspace and see what we can do. Let's say that you are given this function. All right. So the function that you're given is f of x equals the square root of x squared plus 1. And you are asked to differentiate this with respect to x. Differentiate the function with respect to x. So df of x dx or dy dx of this function here, the square root of x squared plus 1. Now, it's actually easier to conceive of this problem as a combination of two functions. So what we'll do is, and the way this works is, we take the part underneath the radical sign, which is x squared plus 1, and we label that u. Okay, it's arbitrary. We're just going to label it u for a minute. And what we're going to do is we're going to take the derivative dy dx of the square root of u, and then we're going to multiply it by the derivative of what u is, which is x squared plus 1. Okay, and so I think the notation they want you to use here is, because this is a u, I think what most texts want you to do is change that x to a u. So I guess I'll do that to make it look more correct. So differentiate y with respect to u, since that's the independent variable inside the expression. And then over here, this will work just fine. So the key here is to remember that, so if I'm actually taking this f prime x equals that. So the way we do this is recall that the square root of u is also u raised to the power of 1/2. So dy du, u to the 1/2 multiplied by d, where do we do this? Dy dx x squared plus 1. Okay, so we'll take this in parts. The derivative here is using the power rule. The derivative is equal to 1/2, because we bring that 1/2 down, times u, okay, raised to the 1/2 minus 2/2, or minus 1. Okay, multiplied by, now let's differentiate. This function is just 2x. Let's see what we get. So I have 1/2 times u. Remember, u is just a placeholder for this. 1/2 u raised to the negative 1/2 power. So that's going to be in the denominator, times 2x. No, this equals 1 over 2 times the square root of u multiplied by 2 times x over 1. Okay, so now let's combine them, multiply them together, and you have 2x over 2 square root u, right? These cancel, the 2's cancel, and now we can substitute our u value back in beneath the radical sign, and we find that we have x over the square root of x squared plus 1. And that equals d f of x dx. And just to clarify notation, I mean, notation is one thing, right? They really want this to say du. Not sure how helpful that is. Okay, so let's do another example before we lose the thread. You can see through that. Let's take an example from Stewart's calculus book. That example that I just worked, by the way, is Stewart Calculus 8th edition, Chapter 2, Section 2.5 on page 152 through 153. The actual example is worked out on page 153 of the 8th edition. Let's see if we can't find another example. Okay, this looks hard. Let's work this out. So it says, let me get up here because we'll probably use a lot of this paper. It says find f prime x if f of x equals 1 divided by the cubed root of x squared plus x plus 1. Before we begin, it might be helpful to rewrite this whole expression. Remember that if I have 1 over the square root of x, that is equal to x raised to the negative 1/2 power. So what this really means is this denominator here refers to the fact that we're taking the square root, and this is the exponent associated with the x, so that it's x raised to the first power, the square root of x to the first. So we can generalize this formula is like if we think of this as m and n, if I have 1 over the nth root of x to the m, that is equal to x raised to the negative m over n. And, oops, you can't see any of it. Okay. And that little rule becomes important here, because it would be very helpful to rewrite our function without this 1 in the numerator. It would just make life a little bit easier. So the first step is to rewrite the function. So far we haven't done any calculus yet. This is just algebra. So here the 3 becomes the denominator. The 3 is going to be the n, and then this whole polynomial, this quadratic in here, is raised to the first power. Okay, so it's going to be raised to the 1/3, the negative 1/3. So here's our new expression: x squared plus x plus 1 raised to the negative 1/3 power. Okay? So now we can do our assignments. Let u equal x squared plus x plus 1. So if I say dy du, the negative 1/3 power of u, and multiply that by du dx. This is where I'm bringing in this right here. I will then take the derivative with respect to x of what I gave u, and that would be x squared plus x plus 1. This is the chain rule. So now I'm like applying the chain rule. Okay, so just follow this logic. Let's just differentiate this thing like it was x raised to the negative 1/3. We'll use the power rule. Use the power rule and differentiate y with respect to u, and say we bring this down right here. This becomes negative 1/3 u raised to the negative 1/3 minus 3/3, because it's minus 1. That's the power rule. Multiplied by, now let's differentiate u with respect to x. Okay, let's differentiate, we're going to differentiate this function up here. So power rule again on this quadratic expression gives 2x plus 1. Okay, and the 1 falls away completely. So now let's keep working. Now we're just going to simplify negative 1/3 u. Now what is negative 1 minus 3? So it gets more negative. It's negative 4 over 3. Okay, there's your times 2x plus 1. Okay, so far so good. Let's keep going. So this is equal to negative 1 over, now let's refer back up here. So what is my m and what is my n? This is my m and this is my n. So I'm going to have the cubed root of u to the 4th power. Okay, and I need to put a 3 right there to make it the cubed root. Alright, and then I'm going to multiply by 2x plus 1 over 1. So let's now actually do that multiplication. I have a negative sign, and that I'll need to distribute. Don't lose that negative sign. Oh, I forgot a 3 over here, because this is 1/3. So this is 3 times the cubed root of u to the 4th. Okay, so sorry about that. This is where I'm getting that 3. Alright, so now I will have a negative 1 that I'll need to distribute over 2x plus 1. But I'll leave it undistributed here for just a minute. 2x plus 1 divided by 3 multiplied by the cubed root of u to the 4th power. Okay, so now let's distribute that negative sign up top. That gives negative 2x minus 1 divided by, and this would be a good time for us to substitute in our u value. Let's substitute that in and multiply 3 in the denominator by the cubed root This is where it gets tricky, okay? Open paren. X squared plus x plus 1 close paren raised to the 4th power. Okay? And that's all under the radical sign. And is there anything we can do to simplify this expression? I don't think so. In your book, if you're looking on page 155, they give the answer in the rationalized form. So they get that Here's how they give the answer in the book. This is book answer. We'll see that it's the same as our answer. Book answer. This is page 155, example 4. This is Stewart, I should say, Stewart. Stewart, 8th edition. Gives this answer. So let's bring this back up. You know, we could write this as negative 1/3 times open paren x squared plus x plus 1 close paren to the negative 4/3 multiplied by this multiplied by 2x plus 1. And I guess they want you to write it like this because you might have to take you might have to differentiate this again to get your second differentiation. But either way, these two things are equivalent expressions. It's always good to verify, right? So let's make sure that we're right. Like, yeah, the book says we're right, but how would we verify it with a calculator? Well, we can use the inderiv function on our graphing calculator to evaluate this derivative. So let's say f prime of, well, we could really do anything, but let's do f prime of 1. So everywhere we see an x, we're going to substitute in a 1. That's negative 1/3 times 1 squared, open paren 1 squared plus 1 plus 1, close paren, raised to the negative 4/3, multiplied by 2 times 1 plus 1. So we really don't know if this is differentiable or if 1 will evaluate to anything here. Let's see what we get. We get negative 1/3 multiplied by 1 squared is 1. 1 plus 1 plus 1 gives 3 raised to the negative 4/3 multiplied by 2 times 1 is 2 plus 1 is 3 multiplied by 3. Okay, so let's keep evaluating this. Okay, this becomes, I'm going to write it this way, negative 1, okay, times 3 all over 3 times the cubed root of 3 raised to the 4th power. And what does that equal? Well, let's see. Negative, let's see, these 3's cancel out. That makes my life a little bit easier. So this becomes negative 1 over the cubed root of 3 raised to the power of 4. So the cubed root of 3 raised to the power of 4. Well, what is 3 raised to the power of 4? That would be 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, and 27 times 3 is, is that right? So that's 21. 6 plus 2 is 8. 81. So, yeah, that's right. 3 to the 4th power is 81. And so what we're looking for here is negative 1 divided by the cubed root of 81. Okay? What does that equal? Let's take the cubed root of 81, which we need to use this open parentheses. Let me clear all this. Open parentheses 81, close parentheses, raised to, and then you got two paths here. You can either do open paren -1 divided by 3, okay, or conversely, you could have gone in here and deleted this and done alpha y equals, okay, we got to delete that 3, and gotten your fraction notation and done -1, or sorry, -4. Nope, it's -1 because I've got 81 already. -1 over 3. Okay, that's what we're trying to find here. Do you see how this is equivalent to that denominator? So let's multiply that out, and then essentially we're taking -1 divided by that, and we get -4.32. -4.326748. Let's verify that that is in fact the correct derivative. So here's how we verify that that's the correct derivative. That our derivative is in fact the correct one. Go to y equals and stick this f of x into y equals. Now it's a little bit difficult to do because it's a complex expression, but you can do it. You can use alpha y equals and put 1 on top, and just put what you see, right? Open paren x squared plus x plus 1, okay, close paren, raised to the 1/3 power, okay. Again, alternatively, if you're used to using this calculator, you could do alpha y equals and then put in the 1/3 power there. And now you've got your whole expression there, entered just like it appears here. Okay, you can't put the cube root symbol in there, but you can put it raised to the 1/3 power. So now that we've got the y equals entered, we hit enter to get it stored in memory, and then second mode to quit. Right? Let me clear the screen for clarity. Now I'm going to hit math, and number 8 gives me inderiv, and so I'm going to differentiate with respect to x, and rather than retype this in, I can hit vars and go to y vars, hit enter on function. You can't see what I'm doing. Let me get out of this. So I'm back here. I want to go grab the function I put into y equals, right? I want to get this function without having to retype it. So I'm back here. Get your cursor inside that parentheses, then hit vars. And you have stored under y vars and under function, enter under function, you've stored the function under y1. So grab that y1, and then remember we evaluated x at 1. So what we're hoping is that when we hit enter here, we get -4.326948. That'll be a verification that we came up with the correct derivative. Ready? Well, that's annoying. What did I do wrong? Make sure that this is entered correctly. The cube root, right? Yeah, x squared. Let me try. Putting in negative 1/3. Oh no, not negative 1/3, just 1/3. And then second mode, do that again. Negative 0.23. What did I do wrong? Did I do this division wrong? Let me see. So I took the cubed root of 81. Oh, okay. All right, I think I know what I did wrong. So I just forgot I did this wrong. So this is I just had this wrong on my paper down here. I didn't complete the exercise. Come on, Michael. All right, so I had negative 1 over 4.326. So when I divide negative 1 by the cubed root of 81, I get negative 0.2311. Okay. So now, that was my mistake. Down here, I just didn't finish the math problem. I found the cubed root of 81, and then I didn't finish by making that the divisor in this division problem. I put this down as the answer, and I didn't make it the denominator of a fraction with negative 1 in the numerator, and then find the quotient. So this was what we actually found on our own, and then in using inderiv we evaluated the function and found the same value for the derivative with respect to x, where x equals 1. So this is it's a good example of where you can make a stupid clerical error and confuse yourself. This verifies that our function does in fact differentiate to either of these two expressions. And sorry for the stupid mistake, right? Because that's annoying, but it happens. Okay. So the derivative with respect to x when f of x is 1 over the cubed root of x squared plus x plus 1 is negative 2x minus 1 over 3 multiplied by the cubed root of x squared plus x plus 1 raised to the 4th power. Okay. We can stop there because the next kind of big topic would be using the chain rule with the quotient rule, and then using the chain rule with trigonometric functions. So we'll make that a different video because this is already 34 minutes long.